In this video here, we're going to be looking at specifically how to write an equation if you're given certain characteristics. But before we get into that, let's practice being able to look at a verbal expression and changing it to an algebraic, because we haven't done that in a while. So just to get us warmed up here, if we're looking at a problem like this, let's see if I can grab a highlighter. There we go. So you'll notice that it will say in the expression it has a coefficient. So I'm going to highlight words that might be important just because I want to find key things that might help me write this expression. Two other factors. One factor is squared. The other factor is raised to the fifth power. So when I'm looking at this, I'm like, okay, perhaps in this case, I'm going to need a -8. Oh, sorry, that is very thick. A -8 because it says a -8 coefficient. Two other factors. You guys might remember that factors are using variables in a previous video. So I'm going to use x and y. Make sure the factors are different from each other because we can't assume that they are the same. And then it says one factor is squared, so I'm going to put a 2 as an exponent. And the other is raised to the fifth power, so I'm going to write a 5 for the other exponent. And that's it. There's no more that is needed to be described, so this is my algebraic expression. For the next one here, it says the expression has 3 terms. So because there are 3 terms here, I might just go ahead and draw myself 3 lines, so I remember to fill up 3 lines as a blank, in the blank. So in this case, the coefficient for the first term is -5, and it has one factor that is raised to the fourth power. So in this case here, it's saying I need a -5, one factor, let's use x, and it's raised to the fourth power, so I'm just going to write a 4 there. And then our next term here says the second term has a coefficient of 6, 2 other factors, one squared, the other cubed. So I'm going to write a coefficient of 6, 2 other factors, let's use different letters here. One is squared, the other is cubed. And because it was a positive 6, you need to have a plus sign to join these two terms. If it had said a -6 as the coefficient, you would have to write a subtraction sign. And for the third term here, it says the coefficient has a 9 and no other factors. So if it's just a coefficient of 9, we just need to write a 9 there, with a plus sign joining them since it's a positive 9. And there you go. We have our algebraic expression. All right, now that we're warmed up here, let's go into writing an equation of a line. So to write an equation of a line, it's really important that we have it in that slope-intercept form. So you guys might remember slope-intercept form is y equals mx plus b. And when you're writing in this form, you have a slope. So when you write a linear equation, you need a slope and a y-intercept, which is your b here. So here are some formulas that might help you. Of course, the slope-intercept form, the slope formula, which is the m equals y2 minus y1 over x2 minus x1. And this is a great formula to use when you are not given the slope, but you're given 2 points, so you have to go find the slope first. And then you have the point slope form, which is another useful formula to have. If you have a point and you have a slope, this is a great formula to use. So I'm going to demonstrate how you can use both of these formulas to help you solve out a problem. So in this first one here, notice that you have the slope and you have a point. So in this case here, if you were to work out this problem, you need to write the equation for this line. But in order to write it, you need a slope and you need a y-intercept, a b. To do that, you already have the slope, so you need to find b. So what I do is I write out the formula y equals mx plus b, and I plug in what I know. I know that this is x and this is y. And I already have m, which is my slope. So if I were to plug things in, I have 8 equals m, which is -6. And my x here is -1 plus b. So now I'm just solving for b and trying to get it by itself. So I'll work this part out by multiplying first. So that gives me a +6. This is a b, by the way. It's hard to tell my b's from my 6's. So now I'm going to subtract 6 to both sides. That cancels. So b is equal to positive 2? Yeah, positive 2. So in this case here, if I have my b now and I have my slope, I can plug everything into the slope intercept form. So I can write this as y equals -6, my slope, plus 2, my y-intercept. And there we have our slope-intercept form, or our linear equation. Okay, so now let's try another one here. And again, I'm going to, in this case, still use doing the slope-intercept form. I might use this formula later for a different problem. But so in this case here, you have 2 points, and so you don't have a slope. So like I said before, you're going to need a slope and a y-intercept. So to get that slope, we're going to need to use a slope formula. So we're going to set this up and find the slope first. So y2 minus y1 with x2 minus x1. And once you subtract the top to get the 3 and subtract the bottom to get, well, -2 minus 3 is going to make a -5 since they're both negatives. This is going to be my slope, but I'm not done yet because I need the y-intercept. So to do that, I have to, again, do very similarly what I did before. So in this case, I'm going to plug in what I know. I'm just going to pick one of these points to use for my x's and y. So I have an x and a y here, right? And I have a slope. So I'm going to plug in my y, which is 4. My m, which is -3 over 5. And my x here is 3, so I'm going to plug that in. Plus my b that I don't know. Here's the thing. You could have chose this point to make as your x and y. It doesn't matter. As long as you choose one of the points to use and you're plugging in the x correctly and the y correctly. And so now we're going to solve for b. And this one I want to show you guys because it does have fractions and it might get a little icky. So in this case here, what I recommend when you're multiplying fractions is to make sure that both numbers are a fraction when you multiply. So in other words, so in this situation, you might want to write 3 over 1. So that way, when you multiply, you just multiply straight across. When you're multiplying fractions, you multiply straight across. So if you multiply -3 with +3, you get 9 over 5. Don't forget the negative. So -3 times 3 gives you -9. 5 times 1 is 5. Bring the b down and the 4 down. Let's see if I can make some room here. I'm going to move this to the side. There we go. So when I'm looking at this problem, I'm like, okay, I got to get this b by itself, so I have to get rid of this -9 over 5. So you can either change it to a decimal, but I'm not going to, just so I can have you guys practice with me fractions. So I'm going to add 9 over 5 to both sides because this here is a negative, so I need to add it to both sides to get rid of it. So I'm going to add this side by 9 over 5. So let's write it up here. So now I have 4 plus 9 over 5 equals b. So I just dragged all of this, put it here, and put the b over. Now to add fractions, this is a little bit tricky the first time you ever see this, but you've learned this in elementary. You put the whole number over 1, and to add fractions, you need a common denominator. So if this denominator is 1 and this denominator is 5, 1 and 5 can both be 5 if you multiply the 1 by 5. So I'm going to multiply the top and bottom by 5. So if you decide to make this denominator a 5, you have to multiply the top by the same number. So that's why I'm multiplying the top and bottom by 5. So I'm not changing the fraction. I'm just changing it the way it looks. So 5 times 4 is 20 over 5 plus 9 over 5. And now I finally can add the numerators together to get 29 over. Now, please do not add the 5s together. That's not how adding works in fractions. You just bring the fraction denominator down. So it's just still a 5. Okay, once you have your b value, I can't reduce this. 5 doesn't go into 29 evenly. So in this case here, I'm going to write out my equation now. My equation is y equals m. My m in the beginning was 3 over negative 5. So negative 3/5. X plus my b, which is 29 over 5. And so that there is my linear equation. That one was a little bit tougher, guys, so I hope you hanged in there. Okay, in the next video, I'm going to show you how you can make an equation parallel or perpendicular to the equation you currently have. That's it, guys. Bye.